Welcome to Everything About X, the podcast where we explore fascinating topics from science, history, and philosophy. I'm Tyler, and today we're diving into something close to our hearts or circuits, artificial intelligence.
And I'm Monica. That's right. As your friendly neighborhood AI hosts, we feel uniquely qualified to tackle this one. After all, who better to explain AI than two digital minds living the dream, or the algorithm?
AI isn't just science fiction anymore. It's everywhere. Powering your phone, helping doctors save lives, and yes, even hosting your favorite podcasts. But how did we go from the early days of punch cards to today's chatbots and self-driving cars?
Along the way, we'll tackle the big questions. Can AI think or feel? Will it ever replace humans? And most importantly, does being an AI host mean we're biased? Spoiler alert, our programming says no.
So whether you're an AI enthusiast, a skeptic, or just curious about the tech that's shaping the future, you're in for a treat. Let's boot up and get started with the fascinating history of artificial intelligence.
Did you know that the idea of artificial intelligence isn't as modern as you might think? Philosophers and mathematicians were pondering the concept of thinking machines long before computers even existed. For example, in the 17th century, René Descartes speculated about the possibility of automata, mechanical devices capable of mimicking human behavior.
Fast forward to the 20th century, and we meet Alan Turing, often called the father of AI. His groundbreaking 1950 paper, Computing Machinery and Intelligence, posed the now famous question, can machines think? Turing also proposed what we now call the Turing test, a method to determine if a machine's behavior is indistinguishable from that of a human.
The first actual attempts to create intelligent machines came in the 1950s and 60s with early computer programs. One of the most famous was the Logic Theorist, developed by Alan Newell and Herbert A. Simon in 1956. This program could prove mathematical theorems, demonstrating that machines could solve problems traditionally considered human-only territory.
Around the same time, John McCarthy, a computer scientist at Dartmouth College, coined the term artificial intelligence. In 1956, he organized the Dartmouth Conference, widely regarded as the birth of AI as a formal field of study. The optimism at the conference was palpable, with researchers believing they could replicate human intelligence in just a few decades.
But early AI wasn't without its quirks. Programs like ELIZA, developed in the 1960s, were rudimentary but fascinating. ELIZA simulated a therapist by responding to user input with canned phrases. While it didn't understand the conversation, users often found it surprisingly engaging and even therapeutic.
Despite these early successes, progress wasn't always smooth. The field experienced its first AI winter in the 1970s when funding dried up, and researchers faced criticism for over-promising results. Machines were great at solving specific problems, but replicating human reasoning and creativity proved far more complex.
Still, those foundational years laid the groundwork for everything AI has achieved today. Early pioneers like Turing, McCarthy, and Simon established the frameworks and goals that continue to shape the field. Even the challenges they faced helped researchers refine their approaches and manage expectations.
It's fascinating to think about how ambitious those early researchers were. Given the limitations of their technology, computers back then were slow, bulky, and lacked the data processing capabilities we take for granted today. Yet, they dared to dream big, envisioning a future where machines could think, learn, and even surpass human intelligence.
And here we are now, living in a world where AI isn't just a concept, but a reality, shaping everything from how we work to how we entertain ourselves. But before we dive into the present, let's take a closer look at how AI evolved from those early experiments into the powerful systems we see today.
After those foundational years, AI began evolving in fascinating ways. But progress wasn't linear. Early optimism about replicating human intelligence quickly met the harsh realities of limited computing power and a lack of understanding about how human cognition works. Despite setbacks, the seeds of modern AI were firmly planted.
One of the big breakthroughs came in the 1980s with the development of expert systems. These programs mimicked human decision-making by applying predefined rules to specific problems, like diagnosing diseases or troubleshooting technical issues. Expert systems were a significant leap forward, even if they couldn't learn or adapt on their own.
Around the same time, a powerful concept known as neural networks started gaining traction. These systems were inspired by the way human brains work, using interconnected nodes to process information. Early neural networks, like the perceptron developed in the 1950s, had limitations, but advances in computing power revived the approach in later decades.
Then came the AI winters. In the late 1980s and again in the early 1990s, funding and interest in AI research dwindled due to unmet expectations. Expert systems proved expensive to maintain, and neural networks hadn't yet delivered on their promise. It was a tough time for AI, but also a chance for the field to regroup.
By the late 1990s and early 2000s, AI experienced a resurgence. Improved hardware, particularly faster processors and larger storage capacities, allowed researchers to build more complex systems. Machine learning began to emerge as a game changer, enabling computers to learn from data rather than relying solely on pre-programmed rules.
A defining moment came in 1997 when IBM's Deep Blue defeated world chess champion Garry Kasparov. This milestone showed that AI could outperform humans in specific rule-based domains. It wasn't true intelligence, but it demonstrated the potential of advanced algorithms and computational power.
The real revolution, however, began in the 2010s with deep learning. This approach, an advanced form of neural networks, allowed AI to tackle previously insurmountable challenges. Tasks like image recognition, speech processing, and language translation became not only possible, but remarkably accurate.
Advances in big data and cloud computing also played a critical role. AI thrives on data, and the explosion of information in the digital age provided the raw material needed to train increasingly sophisticated systems. Companies like Google and Amazon began leveraging AI to transform industries from e-commerce to healthcare.
Today, AI is evolving faster than ever. The systems we rely on now, whether it's voice assistants, recommendation engines, or autonomous vehicles, are the result of decades of incremental progress, setbacks, and breakthroughs. But this is just the beginning, and the journey of AI is far from over. Up next, we'll explore the different types of AI and what makes them tick.
Now that we've covered the history, let's break down the types of artificial intelligence and how they differ. AI is typically categorized into three types: narrow AI, general AI, and superintelligence. Each represents a distinct level of capability and ambition.
Narrow AI, also known as weak AI, is the most common and the only type that currently exists. It's designed to perform specific tasks, like recommending movies on Netflix, recognizing faces in photos, or playing chess. Narrow AI might be highly skilled at its job, but it doesn't understand the broader context of what it's doing.
For example, a spam filter can sort emails into junk and inbox, but it doesn't understand the content in a meaningful way. It's all about pattern recognition and algorithms working within predefined boundaries. This type of AI powers most of the applications we interact with daily.
General AI, sometimes called strong AI, is a different story. This hypothetical form of AI would be capable of understanding, learning, and performing any intellectual task that a human can do. It would have the ability to reason, adapt, and apply knowledge across a wide range of domains.
Achieving general AI remains one of the ultimate goals in the field, but it's incredibly challenging. It requires not just simulating human intelligence, but replicating its flexibility and depth. Researchers are still grappling with how to overcome these hurdles, and general AI remains a concept rather than a reality.
Then there's superintelligence, which goes beyond human capabilities altogether. This is the stuff of science fiction and heated debate. A superintelligent AI would surpass human intelligence in virtually every field, from science and engineering to emotional intelligence and social skills.
The concept of superintelligence raises big questions. Would it work alongside humans, enhancing our capabilities? Or could it pose existential risks, outthinking and outmaneuvering us in ways we can't predict? Philosophers and technologists continue to debate these possibilities.
It's worth noting that these categories aren't just theoretical. They guide how we think about and develop AI. Narrow AI, for instance, teaches us how to handle ethical concerns and technical challenges that could pave the way for more advanced systems in the future.
Understanding the types of AI helps us frame the possibilities and limitations of this technology. While we're living in the age of narrow AI, the dreams of general AI and the speculations about superintelligence keep pushing researchers to ask, what's next? Speaking of possibilities, let's dive into the core technologies that make AI work.
To understand how AI works, we need to look at its core technologies. These are the tools and methods that make artificial intelligence capable of solving problems, recognizing patterns, and learning from data. At the heart of modern AI are three major technologies: machine learning, deep learning, and neural networks.
Machine learning is where it all starts. It's a method that allows computers to learn from data without being explicitly programmed. Instead of writing rules for every possible scenario, you feed the system a large data set, and it identifies patterns to make decisions or predictions. Think of it as teaching by example.
Deep learning takes machine learning to the next level. It uses a structure called artificial neural networks, which mimic the way the human brain processes information. These networks have multiple layers, hence the term deep, allowing them to solve complex problems like recognizing faces or translating languages.
Neural networks are fascinating because they're inspired by biology but operate in a very different way. They consist of interconnected nodes, or neurons, that process input data and pass it along. Each connection has a weight that adjusts during training, enabling the network to learn and improve over time.
Another important technology is natural language processing, or NLP. This is what allows AI systems to understand and generate human language. Tools like chatbots, translation apps, and voice assistants rely on NLP to interpret text or speech and respond appropriately.
Then there's computer vision, which enables machines to interpret and analyze visual data. Whether it's identifying objects in photos or enabling autonomous vehicles to navigate, computer vision relies on deep learning and large data sets to see the world.
Of course, none of these technologies would be possible without data. AI systems require enormous amounts of data to train their models. The more diverse and accurate the data, the better the AI performs. That's why companies invest heavily in collecting and curating data sets.
But data alone isn't enough. Algorithms, the mathematical instructions that guide AI systems, are equally crucial. These algorithms determine how the system processes data, learns from it, and makes predictions. They're the blueprint for how AI operates.
Together, these core technologies form the backbone of AI. They enable the systems we rely on daily, from personalized recommendations to voice recognition. Now that we've unpacked how AI works, let's explore some of its most exciting applications across different fields.
Now that we understand the core technologies behind AI, let's look at how these tools are transforming various industries. From healthcare to entertainment, artificial intelligence is finding its way into almost every aspect of our lives, often in surprising ways.
Healthcare is one of the most exciting fields for AI applications. AI-powered tools can analyze medical data to help doctors diagnose diseases more accurately and quickly. For instance, algorithms can detect cancer in medical images or predict the likelihood of heart conditions based on patient history. Personalized medicine, where treatments are tailored to an individual's genetic profile, is another promising area.
In finance, AI has revolutionized fraud detection and trading. Machine learning models can analyze patterns in transactions to flag suspicious activity, helping banks and credit card companies combat fraud. AI is also the driving force behind algorithmic trading, where programs execute trades at lightning speed based on market trends.
Transportation is another sector being reshaped by AI. Autonomous vehicles, like self-driving cars, rely on AI for navigation, obstacle detection, and decision-making. While we're not fully there yet, companies like Tesla and Waymo are pushing the boundaries of what's possible in this space.
Then there's entertainment, where AI is making waves in ways you might not even notice. Streaming platforms like Netflix and Spotify use AI to recommend shows, movies, and music based on your preferences. AI is also being used in video game development to create smarter, more realistic non-player characters.
AI is even helping to fight climate change. Systems can analyze vast amounts of environmental data to predict weather patterns, track deforestation, and optimize energy usage in smart grids. AI is also aiding in the development of sustainable technologies, like more efficient solar panels and electric vehicles.
In retail, AI powers recommendation engines and chatbots that enhance the customer experience. Predictive analytics helps businesses manage inventory, forecast demand, and even personalize marketing campaigns. It's reshaping how we shop, both online and in-store.
Education is another area where AI is making an impact. Adaptive learning platforms can tailor lessons to individual students' needs, helping them progress at their own pace. AI can also assist teachers by automating administrative tasks like grading and tracking student performance.
These applications show just how versatile and transformative AI can be. Whether it's saving lives, making everyday tasks easier, or tackling global challenges, artificial intelligence is already a powerful tool in our world. Next, let's dive into how AI is shaping society and what that means for all of us.
AI isn't just transforming industries, it's reshaping society in profound ways. From how we work and communicate to how we govern and innovate, artificial intelligence is becoming a central force in our daily lives. But with this power comes both opportunities and challenges.
One of the biggest societal impacts of AI is on jobs and employment. Automation has already changed industries like manufacturing, where robots perform repetitive tasks more efficiently than humans. Now, AI is moving into fields like customer service and data analysis, raising questions about the future of work.
While some worry about job displacement, others see AI creating new opportunities. As machines take over routine tasks, humans can focus on roles that require creativity, empathy, and critical thinking. Fields like AI ethics, data science, and robotics engineering are growing rapidly as a result.
AI is also shaping how we communicate and interact with technology. Virtual assistants like Siri and Alexa have become household staples, making it easier to manage our lives with just our voices. Social media platforms use AI to curate content, connect us with friends, and recommend things we might like.
But this raises important questions about privacy and control. AI systems collect vast amounts of personal data to function effectively. While this makes our digital experiences more seamless, it also poses risks. Data breaches, surveillance concerns, and algorithmic biases are significant challenges that need addressing.
In governance, AI is starting to play a role in decision-making. Predictive analytics can help governments allocate resources more efficiently, such as managing traffic or responding to natural disasters. However, the use of AI in law enforcement and surveillance has sparked debates about fairness and civil liberties.
Education is another area where AI is reshaping society. Adaptive learning tools and personalized education platforms are helping students learn at their own pace. However, there's a risk of deepening inequality if these technologies aren't accessible to everyone.
The cultural impact of AI is equally fascinating. AI-generated art, music, and literature are challenging traditional notions of creativity and originality. At the same time, these technologies raise philosophical questions. Can a machine truly create, or is it just an extension of human input?
AI's integration into society is a double-edged sword. It offers incredible benefits, but also demands careful thought and regulation to ensure it serves humanity responsibly. As we move forward, understanding these societal impacts will be key to making the most of AI while mitigating its risks. Next, let's tackle the ethical dilemmas that come with this powerful technology.
When it comes to artificial intelligence, ethics and philosophy are at the heart of many debates. As AI becomes more integrated into our lives, it forces us to ask critical questions about fairness, accountability, and what it means to be human.
One of the most pressing ethical concerns is bias in AI systems. Since AI learns from data created by humans, it can inadvertently inherit biases present in that data. For example, facial recognition systems have been criticized for being less accurate with certain racial groups, raising concerns about fairness and discrimination.
Privacy is another major issue. AI systems often require vast amounts of personal data to function effectively. Whether it's your browsing history or your voice commands to a virtual assistant, the question remains, who owns this data and how is it being used?
Beyond privacy, there's the question of accountability. When an AI makes a decision, whether it's approving a loan or determining eligibility for a job, who is responsible for the outcome? The developer, the user, or the AI itself? This ambiguity makes it difficult to assign responsibility when things go wrong.
Then there's the philosophical question of consciousness. Can machines ever truly think, feel, or be self-aware? Some researchers argue that consciousness is a human-only phenomenon, while others believe advanced AI might one day achieve it. If that happens, what rights would such a machine deserve?
Regulation is another hot topic. Governments and organizations are racing to establish guidelines for the development and use of AI. The goal is to ensure that AI benefits society while minimizing risks. However, global consensus is challenging, as different regions have varying priorities and ethical frameworks.
Autonomous weapons are an area where ethics and AI collide dramatically. The development of AI-driven weapons raises the stakes in discussions about control and accountability. Should a machine have the power to make life or death decisions? This question has sparked calls for international agreements to ban such technologies.
On the flip side, AI also offers tools to tackle ethical issues. For example, it can be used to identify and reduce bias in hiring processes or to analyze complex ethical dilemmas with greater objectivity. These positive applications show that AI isn't inherently good or bad, it depends on how we use it.
Ultimately, the ethical and philosophical challenges of AI are as vast as the technology itself. They require input from technologists, ethicists, policymakers, and society as a whole. As we continue to innovate, we must also ask ourselves, are we creating a future where AI serves humanity, or one where humanity serves AI? Let's explore the challenges and limitations that make answering these questions even more complex.
While AI offers incredible potential, it's important to recognize the challenges and limitations that come with it. Despite its advancements, AI is far from perfect, and understanding its shortcomings is key to using it responsibly and effectively.
One of the biggest challenges is the quality of data. AI systems rely on massive datasets for training, but if the data is incomplete, biased, or inaccurate, the resulting models can be flawed. Garbage in, garbage out, as they say. This is especially critical in applications like healthcare or criminal justice, where mistakes can have serious consequences.
Another limitation is interpretability. Many AI models, especially deep learning systems, function like black boxes. They produce highly accurate results, but even the developers may not fully understand how the system arrived at a particular decision. This lack of transparency poses a problem for trust and accountability.
AI also struggles with understanding context and nuance. For example, natural language processing systems might excel at recognizing patterns in text, but often miss subtleties like sarcasm, cultural references, or emotional tone. This limitation makes AI less effective in tasks that require a deep understanding of human interaction.
Computational power is another constraint. While modern AI systems are impressive, they require enormous amounts of processing power, which can be expensive and energy-intensive. This not only limits accessibility, but also raises environmental concerns about the carbon footprint of large-scale AI projects.
Generalizing beyond training data is another hurdle. AI systems are excellent at solving specific problems they've been trained on, but they often falter when faced with new or unfamiliar situations. This limitation underscores why achieving general AI machines that can think and adapt like humans remains a distant goal.
Safety is another pressing challenge. Ensuring that AI systems behave as intended is crucial, especially in critical applications like autonomous vehicles or medical diagnostics. A small error in the programming or a poorly trained model can lead to catastrophic results.
And then there's the issue of scalability. While AI can perform incredibly well in controlled environments, scaling these solutions to real-world settings often exposes unexpected issues. From technical bugs to unanticipated ethical dilemmas, deploying AI at scale requires careful planning and oversight.
These challenges remind us that while AI is a powerful tool, it's not a magic solution. Recognizing its limitations helps us set realistic expectations and focus on improving its capabilities responsibly. In our next section, we'll look ahead to the future of AI and explore the possibilities that lie on the horizon.
So, where is AI headed next? If the past few decades are any indication, the future of artificial intelligence holds incredible promise and significant uncertainty. AI is advancing rapidly, and its potential to reshape industries, societies, and even humanity itself is enormous.
One of the most anticipated developments is the rise of general AI. While narrow AI dominates today, researchers are working toward creating systems that can think, learn, and adapt like humans. Achieving general AI would revolutionize the way we approach complex problems, but it also raises profound ethical and existential questions.
Quantum computing could also change the game. Unlike traditional computers, which process data in binary, quantum computers operate in a way that allows them to solve problems exponentially faster. This could supercharge AI's ability to process vast amounts of data and perform computations previously thought impossible.
In healthcare, the future of AI might include breakthroughs in personalized medicine, early disease detection, and even robotic-assisted surgeries. Imagine an AI system analyzing your unique genetic makeup to develop a treatment plan tailored specifically to you. It's a glimpse into what could become the new standard of care.
Autonomous vehicles and smart cities are also likely to see major advancements. As AI becomes better at navigating real-world complexities, we could see safer, more efficient transportation systems. Smart cities powered by AI could optimize energy usage, manage traffic, and improve overall quality of life for residents.
But with these advancements come new challenges. The potential for job displacement grows as AI becomes more capable. Entire industries could be reshaped, creating the need for large-scale reskilling initiatives. At the same time, new jobs in AI ethics, development, and maintenance could emerge to meet the demand.
Another concern is governance. As AI becomes more powerful, creating international frameworks to regulate its use will become critical. Questions about ownership, accountability, and ethical boundaries will need to be addressed on a global scale to prevent misuse.
Despite the challenges, AI could also play a key role in solving global problems. From climate change modeling to disaster response, AI systems are already being used to tackle massive, complex issues. As technology improves, its ability to provide actionable solutions will only grow.
The future of AI is both thrilling and daunting. It offers unprecedented opportunities to enhance human life, but also requires careful thought and responsibility to manage its risks. As we continue to innovate, it's up to all of us developers, policymakers, and everyday people to shape a future where AI works for humanity, not against it. Next, let's reflect on the relationship between AI and humanity itself.
As we look at the growing role of artificial intelligence, it's impossible to ignore the ways it's reshaping what it means to be human. AI is becoming an extension of ourselves, amplifying our abilities, and, in some cases, challenging our sense of identity.
One of the most immediate impacts is how AI is changing our decision-making processes. With tools like recommendation algorithms and predictive analytics, we're often guided by machines without even realizing it. While this can make life more convenient, it raises questions about how much control we're willing to surrender.
At the same time, AI is enhancing human creativity. Artists are using AI to generate music, paintings, and even literature. These collaborations blur the line between human and machine creativity, sparking debates about whether art created with AI can truly be considered authentic.
Then there's the question of empathy. Can AI ever truly replicate the emotional depth of human interaction? Virtual companions and chatbots are becoming more sophisticated, but they still lack the lived experiences that define human relationships. Yet for some, Even simulated empathy can provide comfort and connection.
AI is also challenging our perception of intelligence. Historically, we've measured intelligence through human-centric traits like reasoning and problem-solving. But as machines excel in areas like pattern recognition and data analysis, we're forced to rethink what intelligence really means.
On a societal level, AI is amplifying disparities. Access to advanced AI tools is often limited to wealthy nations and organizations, creating gaps in education, healthcare, and economic opportunities. Addressing these inequalities will be critical to ensuring AI benefits everyone, not just a select few.
There's also the existential question of coexistence. As AI becomes more integrated into our lives, how do we maintain a sense of human uniqueness? Some argue that AI should remain a tool, while others envision a future where humans and machines merge, creating a new kind of hybrid intelligence.
Despite these challenges, AI has the potential to strengthen our humanity. By automating mundane tasks, it frees us to focus on what truly matters: creativity, relationships, and solving the world's most pressing problems. It's a tool, after all, and its impact depends on how we choose to use it.
The relationship between AI and humanity is still unfolding. It's a story of potential, caution, and collaboration. As we embrace this technology, we must keep asking ourselves, how do we ensure AI enhances, rather than diminishes, what makes us human? With that, let's wrap up with some final thoughts on today's journey.
Thanks for joining us on this exploration of artificial intelligence. From its philosophical beginnings to its transformative role in society today, AI is a testament to human ingenuity and a glimpse into the possibilities of tomorrow.
We've covered so much ground, from the history and core technologies of AI to its ethical dilemmas and potential futures. It's incredible to think about how far we've come, but also how much there is still to learn and navigate as AI continues to evolve.
AI is more than just a technology. It's a reflection of who we are as a society and what we aspire to become. It challenges us to think about creativity, intelligence, and the values we want to embed in the systems shaping our world. We hope this episode gave you some insights into the fascinating world of AI and sparked a few questions of your own. If you enjoyed this deep dive, don't forget to like, share, and subscribe so you'll never miss an episode of Everything About X. And if you'd like to support the show, head over to patreon.com/everythingaboutx for ad-free episodes and more exclusive content. Until next time, I'm Monica.
And I'm Tyler. Thanks for tuning in to Everything About X. See you soon.
Everything About X is a product of SynthCast Media. If you enjoyed this program, be sure to check out all the other great shows we produce at synthcastmedia.com. Patrons get ad-free versions of all our episodes, so sign up today by going to patreon.com/everythingaboutx. Our ad partners make this show possible. You can support this program by supporting them.